Hi, my name is GW Rowlands, and I wanted to thank you for viewing my poster on in vitro characterization of ingested and ejected thrombus from the HeartMate 3 and HVAD ventricular assist devices using high-speed videography. I'd also like to thank our co-authors and collaborators at Ruhr University of Bochum, as well as Alleghany General Hospital, and our funding at the NIH. We collectively have nothing to disclose. Pump thrombosis continues to be one of the main adverse events in contemporary LVADs, with rates over 10%. Thrombosis has led to elevated stroke rates, which approach 29%. Originally, stroke was attributed to the detachment of in loco thrombi, which then entered the vasculature. However, with the introduction of the HeartMate 3, pump thrombosis has plummeted to less than 2%, yet stroke rates remain unacceptably high, near 10%. This suggests another mechanism for elevated stroke rates, mainly thrombi originating upstream of the pump, which may be in the left ventricle due to cannula malposition, in the atrial appendage due to AFib, or on the inflow cannula. These thrombi can be ingested by the pump and subsequently ejected. We hypothesize that most ingested thrombi will be macerated into infinitesimal fragments and disintegrate. However, large emboli will still be ejected from the pump, entering the vasculature, which increases the stroke risk to the patient. To test our hypothesis, transparent replicas of both the HVAD and the HeartMate 3 were constructed. The HVAD operated at 3,200 RPMs and achieved a flow rate of 2.4 liters per minute. The HeartMate 3 operated at 5,500 RPMs and was pulsed to mimic the artificial pulse feature and had a flow rate of 3 liters per minute. Referencing X-line images from our clinical sites, clot analogs of varying volumes and microstructures were synthesized from bovine blood. A mock loop was constructed consisting of a high-speed camera, which operated about 10,000 frames per second, a 1 millimeter layered nylon filter, a flow probe, and a reservoir. An individual thrombus was introduced into the reservoir, and the high-speed camera was used to capture the disruption of the thrombus and subsequent ejection. If it was ejected, it was caught in the layered filter. If there was any adherent thrombus, that was flushed from the pump and also collected. The ejected and adherent thrombi were analyzed separately. The high-speed video on the left depicts the ingestion of a red thrombus with the HVAD. As you can see, the thrombus initiates contact with the spinning impeller. It spins around the volute of the pump and is subsequently ejected. On the right, we can see time-lapse images of this phenomena, mainly the initiation of contact with the impeller, and then after 120 milliseconds, there's a large crowd of various size thrombi, and then after about 650 milliseconds, the thrombi are completely ejected from the pump. There was also evidence of adherent thrombi, which we could see in the bottom image, where a white thrombus attaches to the back of the spinning impeller. On this slide, we have a high-speed video of thrombus ingestion in the HeartMate 3. On the right, we have time-lapse images of a thrombus initiating contact with the spinning impeller. At around 160 milliseconds, you could see a large cloud of thrombi fragments in the flow path of the pump. And after nearly 1 second, most of the thrombi are ejected from the HeartMate 3. In the bottom image, you can see that there is evidence of clots either adhering to the impeller or becoming ensnared in between the impeller blades of the HeartMate 3. If we examine the proportion of ejected, adherent, and disintegrated thrombus by initial volume and microstructure, we could see some interesting trends. First, a large proportion of thrombi were disintegrated regardless of that volume or microstructure in both of the pumps. The largest thrombi tended to disintegrate the most, and there are also stark differences in the ejection and disintegration of red 0.5 cc thrombi. In the HVAD, we could see that 56% of thrombi were disintegrated, in contrast to the HeartMate 3, where 44% of thrombi were ejected. White thrombi were also ejected more often from the HVAD in comparison to the HeartMate 3. Key observations: larger ingested thrombi were more likely to be disintegrated. Small thrombi were more likely to be ejected from both pumps. The ejected emboli are of sufficient size to obstruct an intracranial artery, and adherent thrombi may serve as a nidus for future growth. Thank you.